Okay, we'll wait for a couple of minutes for people to join and then get started. In the meantime, if you have any doubts or questions in any of the content covered so far, please post your doubts and questions on chat. Since today is the last live session, I would like to answer as many of the questions as I can. So I might take them up either now or towards the end of the session, but please post your questions on chat so that you can get them cleared. We'll start in a couple of minutes. Okay, let's get started. So yeah, okay, let's get started. Hope you can hear me and see my screen properly. If not, leave a message on chat. So welcome to the week 12 live session of the Operating Systems Fundamentals course, and this will be our last live session, so make sure to ask all your doubts and get them cleared today. In case there are doubts beyond this session and till you have your exam, I think the discussion forum is always there, and there are other TAs who are specifically supposed to answer questions there. So you can also use that to get your doubts clarified. But in case you have any questions today, please feel free to bring them up. And in case we run out of time, I will address them through slides and then share them in the same deck. So look out for the slides. The links will be posted on the course page, so you can get the slides and the recording from there. Okay, so a quick recap of all the topics that were covered in week 12. So we were already looking at the IO and file systems part. So we briefly spoke about a couple of things, I think, with memory management, like pre-paging and some aspects of paging. Then we moved on completely to storage and IO. So we started with a recap of the storage device hierarchy. Then we looked into hard disks and their mechanism and disk structure and all of this. Now remember that disk is a term that is generically used, right? So you'll see them used for both HDDs and SSDs. But a lot of the mechanism that we studied in class, the disk arm and the disk head and the sectors and cylinders and tracks, right? That might be different for different classes of disks. Like SSDs are fundamentally different from HDDs, right? So the mechanism they use for all of this is also different. So that's something you should keep in mind. Because at the time the classic textbooks were written, HDDs were the prominent mode of IO that was used everywhere. So a lot of people still talk about the rotating arm and the sectors and tracks and all of that, but remember that there are newer storage media that are coming in which don't have all of these. Then we spoke about disk scheduling, and we looked at a bunch of algorithms like FCFS, different versions of scan and look, and SSTF. We spoke a little bit about reliability and redundancy. This is also a fairly important topic. Redundancy is very important because you don't want to have data loss, and failure should be more of a norm when it comes to hardware, right, rather than an exception. So for instance, many of you people before, so today I think most of us store our photos and data on the cloud, right? But 10 years ago, a lot of us used to keep all our data on a hard disk, and the more paranoid of us would keep 2 or 3 copies, saying, oh, my hard disk might get corrupted, but I can't afford to lose this data. It's the same idea, right? So even when we push data to the cloud, remember that ultimately at the cloud there is similar kind of hardware. In fact, in many places, commodity hardware, as in hardware that is cheap and easy to procure, is what is used. And so how do you guarantee? And with commodity hardware, failure is a norm rather than an exception. Disks fail all the time, and that's the same whether it's for you or for Google or Microsoft, right? But they can't come back and tell you, hey, one of our disks failed, so your data is gone. So reliability is something that must be guaranteed at a software and application level, regardless of the hardware failure and flaws. So this is an interesting idea. You basically have unreliable hardware, but you're promising your end user reliability. So how do you do that while also guaranteeing performance? For instance, if you asked Google to save a photo, if it tries and saves it to 10 storage media that are present in different parts of the world, sure, your data would be very reliable, but Google's service and performance would degrade because it has to send this data over the network to those various different places, and servicing your request might take more time, right? So guaranteeing reliability and redundancy in a performant way is very important, especially in today's era of cloud. So this has gone far beyond a one machine problem now. It is at a data center level. So things like RAID, you'll hear a lot of these, RAID, NAS, SAN, right? Storage area network, NAS, and all of these things. So there's a lot, and typically IO is the slowest, right? Whether it is disk IO or network IO, right from HPC, which is all supercomputers and a lot of data intensive computation, right from there till the very smallest computation that you can think of, you'll see a lot of focus on IO, both network and disk IO. So these are some important things to keep in mind when we think about IO. And then we speak about files and directories. We looked at different types of access and different types of directory organization, and most importantly, how do you control access to these files, right? And then we also briefly looked at disk allocation. So today's questions will be based on these topics, and feel free to post any doubts that you have whenever you want during the session. I'll mostly take them up once these allocated 10 questions are done. So yeah, so before we move to the 10 questions, there was a question in the previous session on the state of a process, right? So we have all these states like new, ready, running, and etc. terminated. So the question was, what exactly happens in the new state? It's not very clear. So in the new state, the process is still being created. So imagine that you give a command that spins up this new process, right? So in the background, what are the things that need to happen? The program is something that resides on disk, so this needs to be brought into main memory. Then any bookkeeping operations that the operating system needs to perform, for instance, it needs to populate the process control block with all the values that are needed for this process to run. This is something that needs to be done. And then there is this, remember that there is this ready queue from which processes are selected to run, right? So first this process needs to be put into that ready queue, which is done by this long-term scheduler. So this long-term scheduler is invoked once a while, right? So whenever it is invoked, it would put this process into the ready queue. So in the meantime, from the time at which you issue a command to create a new process to the point where it goes into the ready queue, it is said to be in this new state. So it is kind of in this transition of being created. It's not yet fully created. A bunch of these operations might be happening. Once all of this is complete, then it is said to be in the ready state. Hope this answers your question. Great. So let's get started. Okay, question 1. Hope this is visible. If we want to set the following protections for a file, what should the command be for it? So there are 3 levels of permissions for read, write, and execute, and there are 3 entities. One is the public, the next is the group, and the next is the owner, and you have various values for each of them. So you are supposed to come up with the value that you pass to chmod for this set of protections. Okay, we have an answer 1B. Anyone else? I'll wait 30 seconds in case people are trying to solve it. Let me know when you have an answer. Any other answers? Do other people agree with B? Anyone? Okay, so we have C as the answer. Okay, anyone else? Okay, let's look at the answer. So it is C, chmod 754. So let's take a quick recap as to what this means and then come back to this question. So this whole thing is about access control of a file. So assuming that one person creates a file, So we moved on from the uni programming computer system, right? It's no longer that one user uses a computer and all the files are accessible only by them. Now we have this notion of multiple users using the same system. So in that case, it's important to be able to decide which files a particular user can access. So Linux and a wide variety of Unix operating systems go by three entities. First is the owner of the file. The next is a group, right? So if you've created a user on a Linux or a Unix based system, you typically add them to different groups. For instance, sometimes you might have wanted a user with sudo access. So you'd say, okay, can you please add this user to the sudo group, right? And you would somebody would have done that for you. Similarly, there are a bunch of groups, right? So what is the access for a particular group is specified by the group access, and then what is it to someone who is neither the owner nor in the group, right? So for a public person, so that is the class of users, and then within that you have three forms of access, right? Read, write, execute. For instance, you might want to share this file with a group, but you might want to specify protection such that members of this group can only read your file, but you are the only person who is allowed to edit this file. So you might want some combination of this, right? Or you might want something else, saying the public shouldn't even be able to read this file. So you can specify all of these things using these permissions. So typically the command that you use to set protection for the file is called chmod. So it takes two arguments. One is this numeric part that you see here, and the other is the name of the file. So this numeric part, the first number comes from the owner permissions, the second from the group, and the third from the public. And in each of these numbers is formed by the 3 bits representing read, write, execute, right? Many times you would have noticed that when you try to execute a file or when you try to write to a file, typically system files, you would get this error saying you don't have permission to access this file, and then maybe you would have used a sudo. So that means that is a consequence of the protection set for that file, and it is intentional, right? Because we don't want files to be a free for all thing. Only intended people should be able to access it. So here's an example. So the owner access is 7 as in this example. That means that the permissions are 1 1 1, which means a 1 for read, write and execute. So let's go back to our question. So the permissions are given here. So for the owner it is 1 1 1, which comes to 7. For the group it is 5, which for the group it is 1 0 1, which comes to 5. For public it is 1 0 0, which comes to 4. So ultimately you end up with chmod 754 file name, which is option C. Any doubts on this? If not, we'll move ahead, because I would like to have at least 5 minutes at the end for any questions you guys have. So let's move to the next question. Which of the following directory organization, in which of the following directory organizations links are used to point to both files and subdirectories? General graph directory, acyclic graph directory, tree structure directory, none of the above. Any answers? C, tree structure directory. Okay. Anyone else? Anyone? Anyone else who thinks there's a different thing as the answer? Okay, let's look at the answer if not. So the answer is actually acyclic graph directory. So if you remember with a tree structure, so unfortunately I don't have the recap for a tree structure, but you can go look this up in your slides, right? So it's not possible with a tree structure, it's not possible to have this sharing of files or directories, and that's the reason we move to acyclic graph directories, where you can have something like this implemented through a link. You can have sharing of both directories and files through a link, and as you can see in this example, right? So that's why the answer is acyclic graph directory here. Any doubts on this? In tree structure, okay, let me look at that. In tree structure also we can point to both. I don't think it is implemented as a link, right, in a tree structure. I myself have to go back and look at the slides, but from what I remember, in both of the others you can't have a link point to both shared, both a file and a subdirectory. But I'll confirm this before I post the slides, and in case there are changes I will put them into the question. But this is also the official answer given by the NPTEL people. Okay, let's move to the next question. In sequential access, how is the file pointer affected by the read next or the write next command? Incremented to the next value, reduced to the previous value, reset to 0, none of the above. Incremented to the next value. Okay, anyone else? Anyone else? Okay, if not, let's look at the answer. It is incremented to the next value. So here's an example. So in sequential access, if you say read next, it reads the next portion of the file, so it automatically advances a file pointer. And similarly in write next, right? So that's, I think, pretty straightforward. Okay, we have one more answer saying A. Great. So I think there are no doubts in this question. We move to the next one. In open file locking system, the advisory access policy denies the access request depending on the lock held and requested, allows the access request ignoring the lock status. The process looks up the status of the lock and decides what to do. None of the above. I don't know if this was covered directly as part of your slides, but let's see. Anyone? Right, I also didn't find it in your slides, so I actually took a snippet from Galvin to help you guys understand this question. But let's see if anyone has an answer. Okay, if there are no answers, let's look at this. So the answer given is C. The processes look up the status of the lock and decide what to do. So let's look at what's there on locking with Galvin, right? So this is from Galvin, so you can go back and find it there. So there are two file locking mechanisms that are available. One is called mandatory and the other is called advisory. And as the name indicates, if it's a mandatory lock, then once a process acquires this exclusive lock, the OS prevents any other process from accessing that locked file. For instance, if a process acquires an exclusive lock on some file called system.log, if you attempt to open that same file from another process, for instance a text editor, the OS will ensure that you cannot access it till this exclusive lock is released. So this will be done by the OS, as in the text editor does not need to do this. The OS takes care of it. So even if the text editor is not written explicitly to acquire the lock, this is taken care of. So this is a mandatory lock. With an advisory lock, the OS will not ensure this. So it is upon the process, or more realistically the programmer who is writing that code, to make sure that it acquires the lock. So for instance, in this example, the text editor should be written so that it manually acquires the lock before accessing the file. So the OS will not ensure that this happens. So it's up to the developers to ensure that the locks are appropriately acquired and released. So going back to our question, we are asking about advisory access policy. So the process looks up the status of the lock and decides what to do, rather than the OS imposing some kind of a mandatory locking. So this denies the access request, allows the access request. Both would be in case of a mandatory locking. In an advisory one, the OS has no role to play. The process decides. Any doubts on this? Okay, let's move to the next question then. Which of the following disk scheduling algorithm should not be picked for systems that place heavy load on the disk? Scan, C-scan, SSTF, all of the above. Okay, C, SSTF. Anyone else? Okay, let's look at the answer. So it is SSTF. Why is it SSTF? So if you remember SSTF, right? So it picks the one with the shortest seek time, right? It's very similar to SJF in that aspect. So what happens as a consequence of doing this? The ones with the shorter seek time are always prioritized, right? So if you have workloads that have a lot of IO requests, it is likely that many of those might be starved because you're always trying to prioritize the ones with the shorter movements. So as a result of that, typically SSTF is not recommended for systems that have a heavy disk load, whereas with scan and C-scan you have a better what do I say, fairness, or the way in which requests are served, right? So it avoids a lot more of this starvation. It's not heavily biased towards shorter seek time. So that's the reason SSTF is not picked for systems that are heavy on IO. Any doubts on this? Okay, if not, we'll move to the next question. Again, I'll remind people, since we are at the halfway mark, today is the last live session. So in case you have any questions in the course so far, please feel free to ask it here. You will not have another live session after this. So this is your last chance to ask questions and get them addressed in a live manner. So feel free to ask. And it's fine if it's from reading an OS textbook or watching some other video outside NPTEL also. If I don't know the answer, I'll tell you so, but I'll make sure to put something in the slides that will help you. So feel free to ask. Okay, moving on. Which of the following disk scheduling algorithms searches in only one direction and the arm goes only as far as the last request before reversing its direction? Look, see look, scan, see scan. Think carefully, because many of these are kind of similar and related. So think and answer this one. Okay, B, see look. Anyone else? Anyone? Okay, let's take a look at the answer. It is B, C look. So let's take a look at all four of these, because I'm sure some of you have forgotten or are wondering what each of these are. So we start with scan, right, which is the simplest thing. So the disk arm starts at one end of the disk and moves towards the other end, and it services requests till it gets to the other end, and the head movement is reversed, and the servicing happens both in the forward and the reverse direction. So now we have a variant of this called C-scan. This is very similar to scan, right? So it again moves from one end of the disk to the other, but when it reaches the other end, it just comes back to the beginning without servicing any requests on the return trip. So the idea behind this is you want it to be a little more uniform in terms of wait time than scan. So for instance, let me get hold of a pen. So if the head is currently here, with scan I move all this way and then come back servicing various requests, and then I service something that is here, right? So a way of providing more uniformity is at least to start here, go here, and then come back here, and then do this circuit, right? So in a way, this request does not have to wait too long. It does not have to wait till not this request, other request. Maybe this was not a great example for the uniform wait time, but basically it avoids this sort of thing where again requests on this back path get serviced, right? It gives you more uniformity. So that's the difference between scan and cscan, just that you don't service requests on the backward path for cscan. Now with look and clook, the difference is that it does not go to the end of the disk or all the way to the beginning of the disk. The traversal is only till the last request in that direction. So let's say end is here and the last request is somewhere here, right? So if I know that the last request is here, I don't need to waste time by going this far, so I'll immediately reverse here, and similarly at the beginning. So look is very similar to scan, except that it doesn't go till the end or till the beginning, and clook is similar to cscan, and it also goes as far as the last request in one direction. So there is a direct kind of relation between scan and look and cscan and clook. So now going back to our question, in which of the following is the search only in one direction? So if the search is only in one direction, that immediately brings down your options to cscan and clook, and then the arm goes only as far as the last request, so that brings down your answer to clook, because in cscan it goes all the way till the end or all the way till the beginning in whatever direction it's going. So hope this is clear, and hope you're not too confused by all four of these. So think of it as two factors, right? So on one axis you have how far it goes to the beginning or the end. The other axis you have the direction, as in, is our request serviced in both directions. So by varying these two parameters, you get a 2 cross 2 matrix, which is 4 algorithms, and that's the four algorithms that you have here. Any doubts on this? Okay, if not, we'll move to the next question. A disk has 200 cylinders. If the initial position of the read-write head is at cylinder 39, calculate the total head movement following SSTF policy for this read request sequence. And you have 4 options here, and this will take a while to work out, but I encourage you to work it out during the live session. So I'll give you the time to work it out. I'll give you a whole 2 or 3 minutes. Let me know when you have an answer. Okay, we have an answer which says B. Okay, anyone else? I'll give you a minute more since this involves working out. Anyone else? Okay. Excuse me. If not, we'll take a look at the answer. So the answer was, one second. Sure. The answer was B223. So we are using SSTF here. So let's first start with that. Let's start with the recap of that. As we were talking about, it's shortest seek time first, right? So in a way, it's like a greedy algorithm. At each step, it tries to be greedy about how much it has to move. So it tries to minimize that, and with the idea that the overall movement is also minimized, right? And as we already discussed, it might cause a starvation. And here's an example in case you haven't seen this before. The head starts at this position and there are these many requests. So you can see that it starts at 53, so it tries to move to the closest, which is 65 and then 67, and then moves to 37 and so on. So the first thing that we have to do is take our read request sequence and the current position of the head. So the current position is 39. So we try to find what is closest to 39. So we have 25 on one side and 84 on the other, and 25 is the closest. So now from 25, 2 is the closest, and then from 2 we go all the way to 84, then to 112, and then finally to 154, and then 188. So now if we have to calculate the total head movement, we take the difference between two consecutive cylinder positions, basically the jumps that need to be made. So 39 to 25 would be the first jump, 25 to 2, 84 to 112, right? This should be 112. So maybe there is a typo. Okay, so now this is counting this jump still, 2 to 84, then 84 to 112, 112 to 154, and 154 to 128. So if you work out the math, you will see that it comes to 223, which is option B. Any doubts on this? Okay, we'll move to the next one then. It's a very similar question with a different algorithm. So again, we have 200 cylinders. Initial position at 39. I think it's the same sequence as before, but calculate the movement using C-look policy now. So again, I'll give a couple of minutes since it's a numerical. In which direction is the head moving? Okay, let's see the question again. It is 39. I think in the example given in your slides, it started moving towards the end first. So we'll assume that for this question. But a more generic question is, does the algorithm dictate the design? I don't think so. Since it says it just goes to one direction, it can be picked either way. But for now, we'll assume that it's moving to the right. Okay, 337 if the head is moving in the higher direction. Okay, but I don't see 337 in the options. I see. Check the calculation once if possible, because I think I worked it out and I got it to be one of these options. Sure, take your time. Okay, A358. Okay, let's look at the answer. It is A358. So again, as a recap of CLOOK, it goes as far as the last request in one direction, reverses direction, but not all the way to the beginning, and it doesn't go to the end also, right? So it comes back to the leftmost request that we have. So the order will be starting at 39. So assuming it moves to the higher end, we go to 84, 112, 154, 188. Then it does not go to 199. It immediately comes back to 2, and again it comes back to 2, not to 0. And then finally it goes to 25. So now if you sum up these jumps, you get 358 as the answer. Any doubts on this? Great. So let's move to the next question. Which of the following is correct about linked allocation? Each block contains a pointer to the next block. Locating a block can take many IOs and disk seats. Reliability issues arise when one of the pointers get corrupted. All of the above. Okay, D, all of the above. Okay, let's take a look at the answer then. It is D, all of the above. So coming back to linked allocation, by definition every block contains a pointer to the next block, and by doing this we avoid external fragmentation, right? Because you have this pointer now and that gives you flexibility as to where these blocks are. But because of this, locating a particular block might take a lot of IOs and these disk seeks. So remember that even though, so this is again a consequence of the logical versus the physical, right? When we think of a file, when we see a text file, we think of it as maybe the text file has 2 or 3 pages, right? So we automatically resort to thinking that these pages will reside continuously on the disk too. But remember that that's only a logical view and they can actually be located anywhere on the disk. The consequence of that is if you have a hard disk, it will involve the seek time, and because one of those pages or blocks might be on one cylinder and the other one is on maybe the extreme most cylinder from that point that you can find, it might take a lot of IO time to just fetch a file, right? So that's a problem. So this is like how you physically lay out the file on the disk, right? So that itself can be a major issue to performance. So in applications where performance is critical, sometimes people even go as far as playing around with exactly where the file is located. But coming back to linked allocation, so if one of the pointers gets corrupted, then you have a problem because you can't find the next block, right? So that, yeah, so I think we went through all the options. So D, all of the above is true. So let's go to the last question for the day. Select the correct statement about indexed allocation. Each of the files has its own index block of pointers to its data blocks. Can be accomplished with multi-level index method. Dynamic access is possible without external fragmentation. All of the above. Okay, we have an answer which is D, all of the above. So let's look at the answer as well. It is D, all of the above. So going back to what indexed allocation is, every file has its own index blocks of pointers to its data blocks, right? So you need an index table for this, and so yeah, this option A we've gone through. Every file has its own index block of pointers. And how do you accomplish this? With it can be accomplished in 3 ways: linked, multi-level index and combined scheme. So B, multi-level index, is also true, and dynamic access is possible in this method without external fragmentation, again because you have this notion of an index block, right, which has a pointer to the data block, so you don't need to worry about fragmentation. So but you still have this overhead of the index block. So all these three are true, and therefore all of the above is true. So this is the last question we have, and I've intentionally kept it open so that if there are any doubts we can take those up. So are there any doubts for today? Okay, no doubts. Anything else overall from the course with all 12 weeks contents? Right, this is the last session, that's why I'm asking many times. Right, go for it if you have a last question. TLB with multiprocessor architecture. That's an interesting one, but let's see if I have content on that. Okay, per core private multi TLBs such as L1. ICC, okay. Where exactly is this from? Is this the doubt, or is this the answer to what happens to a TLB in the multi-core architecture? Okay, L1 and L2 TLB from Tannenbaum and Stalling. Okay, I see. Okay, this is what is given there. Chance of redundancy and predictability. Okay, inter-core cooperative TLB and shared last level TLB. Right. So this is actually a kind of a research question, right? It's not typically there in textbooks. So that's why you find a lot of papers doing different things around this. In fact, I kind of got into this question when I saw some research paper as well. That's why I kind of asked it. So I don't have a standard answer to how it could be done, but there are multiple ways that people have proposed. And if I come across an easy way that's kind of understandable and relatable, I will put that into the slides. But I think the whole point is to have that curiosity about thinking, right? That was the point of asking those questions, right? So I think with NPTEL, right, most students are expected to be at an undergrad level, and the point is to have questions that directly test your recall primarily, and then your understanding of concepts and being able to apply that to problems, right? But there is not much of a focus on the design itself. What are the different ways to do things, and what are the consequences that has on something? And that's fair considering that it's targeted towards undergraduate students. But I always like to get people thinking about some of these things, right? It's okay if you don't find the answers, or it's okay if you're not able to understand those research papers that you find, but these give you an idea of how complex it can be to design a real world system, and it also helps you appreciate some of that complexity better, and that will definitely help going forward. For instance, when people pursue a master's course, they're often asked this kind of questions, right? And then sometimes it leads to a gap because your undergrad methods of testing and methods of evaluation highly rely on not very design oriented questions, right? So thinking about these things, I think, are very helpful towards both understanding and appreciating the subject better, and also for building up your own curiosity, right? If you're reading a subject, it's not just to understand what the textbook says about it, because in many cases the textbook is 30 years old. If you're reading operating systems today, you should also be curious about what's happening today and what are the future trends and things like that, right? So thinking about some of these questions help build up that kind of curiosity, and that's always good. So that's one of the reasons why I don't answer all of them in the next class, because some of them are intended to be those open questions with multiple answers that will require a lot of digging around to actually understand that. But in trying to do that, you might find something that really interests you, and that might give you some idea that you implement, and that's how typically you get into the depths of the subject. So yeah, glad that you looked into it and that you found something. And yeah, I think we are at time, so I won't go into too much of the details of this. Great, same here. I think you're one of the few people who have attended all the sessions consistently, so I wish you all the best, and both for your NPTEL exams and otherwise. And in case there are any questions that you want answers to, and if you're not able to get answers from the discussion forums, feel free to write to me. I think my email ID will be there as part of the slides, so feel free to write to me, and I can answer your questions. Oh, I don't have my, okay, I'll add it before I post it in today. Sure, I can do that, no worries. But officially, the discussion forum is the place for queries, especially if you have questions on some assignment key and all of that. Make sure to ask it there, because that's where the official NPTEL folks would look at. But if there's something that you don't find answers to, okay, sorry to hear that. There are supposed to be people regularly monitoring the discussion forum and answering that. So maybe I will leave a feedback to the NPTEL team on that, and they can improve that. But yeah, feel free then to write to me for questions. I don't go and check that, because I don't have the permissions to respond, as well as it's not part of what I'm supposed to do, so I don't do that. But feel free to write to me. Great. If there's nothing else, we can end today's session. Thank you so much for joining.